Hi, this video is about deep learning lesson to basics in Keras. So today we have an interest in programming of four tasks. So the first task is about using the each object in the source code and to plot the loss and accuracy for both training data and validation data. Whereas the second one is about plotting one of the images in the test data, and then we have to inference to check what the inference to check what is the prediction of that model. Like we have to find the numerical value of that image. So now let's see the code for that. So I've been combined the task 1 and task 2 in the same only one script. Now basically here we are displaying the first image in the training data, and then we are passing the data here. We are converting the data to float and scale value between 0 and 1. We are just doing the scaling, and we are creating the network. So now here we are finding the evaluation. We are doing the evaluation of loss and accuracy, finding the loss and accuracy of the model, and then we are taking image index. With the help of the image index, we are plotting the image, and then we have to predicting the image, like the value or numerical value of that image present in that. So and again we are plotting the model for accuracy and model for loss. Now let's see the code. Now let's run the code and see what will be the output. So basically this should be taking a lot of time, so I will be pausing the video and I will be showing you the output. So yeah, here you can see the first image in the dataset, training dataset. I'll be closing that. Now we can see a digit from the test data image. Now it's 6. Now let's see. So yeah, this is the accuracy thing. Again the epoch and the loss between the trained data and test data here. So here you can see the predicted digit was 6, and here you can see the loss was 0.07 and the accuracy was 0.98. Yeah, now let's see the task 3. So that task 3 was we have to hidden layers, right? So now with relay activation, now we have to change the number of hidden layers and the activation to timers or sigma and see what happens to the loss and accuracy here. So yeah, now here you can see the code for that. So now I've added the more dense layers with activation layer equal to timers and sigma and softmax. And now let's run the code and see the output for that. Again here you can see the first image from the dataset. So here now we can see the accuracy graph here, or we have plotted accuracy is epoch, and here we can see the loss here. So now the accuracy loss was 0.081 and the accuracy is 0.97. So now here you can see the loss is 0.081 and the accuracy is 0.97 after adding the dense layers. So now we have to run the same code without scaling the images, and let's see how the accuracy changes. So the task for is the same code, just we are connecting the scaling of the image. So now let's see how does the output will be. So yeah, again you can see the first two image from the dataset. So now you can see the different data 6. So this is the accuracy to the data and test data, and this is the accuracy so it was from 20 test data here. So now you can see the loss is 0.15 and the accuracy is 0.95. So there are tasks 3 without with the scaling the loss was around 0.08 and the accuracy was 0.997. But here after we are removing the scaling part, I mean when we are not doing the scaling, the loss is getting increased and the accuracy is getting decreased. So this is the observation of them, and the predicted digit was 6. Thank you.